Okay. You are seeing the screen? It's okay for you? Everybody's seeing the screen. Okay. Thank you. So I'm going to speak about the evolution of construction through the times, okay, till the recent days. As you see from a short index, I'm going to cover since prehistory till our days to see what our colleagues, the civil engineers, have done through the old times. What is basically civil engineers? What are the civil engineers and what is the goal of the construction? Mostly the objectives of what we do, of objectives of construction is basically to build buildings, to build monuments, to build bridges. All these things have, and it is important to have this concept, we do this because we have a target. And what are the targets are when we do buildings, it's something to protect the persons, the family from the environment. When we do bridges, it's to have as the objective of passing an obstacle, to pass a river or something like that. We build roads to facilitate the movement of the persons. So the functional aspect of all our constructions is always the goal of the constructions. Of course, to achieve these functional results, we need to have safe constructions. And what it means safe, it's buildings that can support the force of the winds, of the seisms, bridges that can support the loads that pass there. So the constructions need to be safe. And besides that, they need to be durable. We like to have constructions that do not degrade with time. We need roads that support the erosion or monuments that are used and they stay for the eternity. So we have already these three main goals of construction: is functionality, safety, and durability. And these are the main goals that we have since the beginning of construction. And how did we did this first construction? At the beginning, we only had basically three materials: the soil, basically the clay that was used in construction, the stone, and the wood, timber or wood. And with these three materials, we built everything that was built till the 18th century. Let's see a little bit more in detail. So soil or earth is the cheapest material that we have. It is a material that the strength is not very high, but it allows very easily to build in the form of compact earth or with the bricks of earth. And we can find it even today in different regions of the world, construction with earth. You see here buildings with several floors built with earth. What is the main characteristic of these constructions? The main characteristics is these constructions appear in places very dry, typical desert situations. Why? Because earth constructions with water, they disappear, they melt. So we can see these constructions only in dry countries. Even in Portugal, we only have this type of constructions in south of Portugal, mainly Alentejo, because it's the driest part of our country. Stone is, as I can say, a kind of better soil. Stone is a material that is the strength is much higher, but it has a problem that in terms of tensile stresses is weak. We can compress stone very strongly, but if we apply a tensile stress, so a tensile stress, it breaks very easily. So stone was used mostly in monuments because it's very durable, but till it was invented the arc solution, the stone was not so much used because if you make a beam of stone, it more easily breaks. Besides that, wood, I would say that was a material that was very much used. It was very much applied, especially in the Eastern world, Asia and so on, but also in Europe. Contrary to stone or earth, wood works well in compression and in tensile stresses, so it was mostly used to make beams. And it was, I would say, the most common material that was used in construction. Unfortunately, the wood has severe deterioration problems related to insects, fungi, or even water. Water degrades very much wood. So most of the construction that was built with wood disappeared, and the old construction disappeared and did not reach our present days. So you know already the objectives of construction, you know the materials that were used in the beginning, and now let us see the real constructions. The first constructions that appear there, they are not real constructions, or the caves. The caves were used, natural caves, so they are not really a construction of the human being, and they were used to protect. It was an easiest way to be protected from the environment. It was the utilization of caves, mostly in stone. But the first building, or let us say the oldest building that is known, is this building that was built in 9000 before Christ. It exists in the south of Turkey today. And it's a special building because it's a temple. It's we are speaking of a period where human being, there was no agriculture yet. Human being lived mostly by hunting animals, and it appears this concept of temple. So the first constructions that we are aware of are basically temples. And you see that the material that was used was stone with, of course, elements related to the religion associated to that temple. But as it was built in stone, we could see it today, mostly 11,000 years after that. Now 9,000, yeah, 11,000 years. Okay. After that, after this period, after this period appeared the agriculture. The agriculture appeared around 4,000 years. So you see a difference between 9,000 and 4,000. It's a lot of time. And with agriculture appeared the concept of city or town. Okay. One of the oldest towns that are known is Uruk in Sumeria, present Iraq. And we think that associated to the temples in some places with development of agriculture, people began to be located. It was easier to do agriculture than to run behind animals to hunt them, and people began to settle. And the appearance of a town or a city, it's quite a new concept, because in the period before, each family or each hunter had to do everything and to find food for his family. when the town appears or the city appears, we begin to see specialized professions. We have the shoemaker that just do shoes, but he can exchange shoes by food. And we have a group of people with each one with its own profession, and the professions exchange materials, and all can survive. And due to this exchange of products appears the writing. These are the first typical writings, because writing appears as a registration of the commercial exchanges among people. It's the first concept of writing is just that. And with the appearance of the city appears the construction of the buildings, but also appears already the drainage systems or the sewer systems. So the problems that existed in a city with 4,000 or now 6,000, but 4,000 before Christ are also the problems that we have in our present cities. All those problems related with communication, water drainage, and so on appear those. So those problems begin to be solved since then time. Now, today they have special problems. As you know, Iraq is not a stable country, and unfortunately, these places are not easy to visit. It seems that Pope is going there in the next days. Well, so basically, with the appearance of the towns or the cities, the buildings, the small houses, are mostly built with stones, with stones in the walls. But when you reach the ceiling or the roof, there you have to put beams, and for the beams you have to put wood, no? And that's why mostly of these old constructions we only have walls, because they are in stone, because the roofs disappeared. They were in wood, and with time they just disappeared. The first civilization, a real civilization with, let us say, a king power or a pharaoh power, is the Egypt. In the Egypt, if you think in Egypt, mostly you think in the pyramids. The pyramids are the tombs of the pharaoh kings. And it's funny because it's the evolution of the pyramids have the solution of some engineering problems. The first pyramid, let us say the step pyramid, is the Saqqara pyramid built by the pharaoh Djoser. And it was a step pyramid. As you see here, it has several steps. Because before this, typically the tombs were just a parallelepipedic tomb close to the soil. And this pharaoh decided to make a bigger one with steps by steps. The next pharaoh, it was Snefru. He decided to make a more uniform pyramid, and instead of steps, he tried to make a uniform pyramid. But he began, as you see here, he began to build with this inclination, and suddenly he had a rupture of the foundations. Because, as you know, when you do, let us say, when you are in the beach, with sand, you try to make a small amount with sand, you know that the inclination has a maximum that is related to the friction of the soil grains, of sand grains. And here is a bit the same. The inclination was too high, and we begin to have a rupture. Hopefully the architect or the engineer at that time understood the problem, and he changed the inclination to a stable inclination of the pyramid. And it was this inclination that was found as stable that was later used in all the other pyramids. How to build these constructions? It's funny. Remember that you have to cut stones of this size from from places with a lot of stone, and you have to cut them, and you have to cut them without any iron, without any steel, let us say. How was this done? Basically, you had to put some fire close to the stone. With that fire, you had some cracks, and after in those cracks, you put some wood, you put water on the wood, and the wood would expand, and the cracks will let us say, expand and will break a part of the stone. And after, to make a regular stone, it was used a friction system, just with a more thick or a more durable stone, typical diorite, that was placed in friction till they reach the final shape. And these elements, after, they were pushed to the place in a kind of I don't know how to call it. It's an element that works by friction and is pushed by several elements. It's a kind of toboggan that is pushed. You can see here an example of a statue that is pushed, and you see this guy that is putting water in front just to reduce the friction. So it was not a transportation with wheels. It was a kind of skate transportation that was used to build the construction. We still have in one of the temples in Egypt those inclination elements that were used to transport the stones. So typically this is of course the reconstruction, but you can see here the skates that are used to transport stones. So it's not only the material, but how to build or prepare the material to make all these constructions. The Egyptians that left all its temples, the temples that you know from Egypt, of course, they are all built in stone because it's durable material, and they understood that. But as they did not use for the temples the arc, they used the beams. You can see here that the beams were at a very small span. You compare, you see the height of this guy. So this beam has 2-3 meters span, because they knew that if the span was too large, the stone will not support and the beam will break. They also invented the columns. The columns, as you see, are built with several segments for construction, because it was impossible to place all an element like this together. And they place it one over the other. And at the end, they used these capitals that were used very large, mostly because the beams that were used were very large. And they also understood the problem with the soil, because the pressure of the column was higher, and the pressure in the soil should be reduced. And to reduce it, they enlarged these elements. So the force divided by a greater area reduced the stress in the soil. And so foots were invented also by the Egypt. So basically, in the Egypt appears the basic elements of construction. One thing that they also used was not invented by Egyptians, was invented in Sumeria, so a few years before, but they used it a lot, is the brick. The brick is a construction element that is very powerful, let us say, because it allows that, as it is a small element, allows that you can make your own house, okay? If you work with stone, you need a lot of people to make a building or whatever. With the brick, you can do it yourself, because it takes more time taking brick by brick, but you can do it by yourself. And besides that, brick is soil. It's basically clay that you put in molds. Here you are putting the clay in the molds. After they stay drying for some time, and after you build the walls or whatever. They also understood that when clay dries, when clay dries, it can break, it can open some cracks, and so they put some vegetable elements inside it to absorb those tensions. So you can see here bricks from those times in Egypt, and you can see here that they began to have the concept of ark. This is an Egypt, let us say, ark from those years. The main problem of the ark is that to build an ark, you need to support the ark till the ark is completely closed, because only that you can take out the support. Or the Egyptians, what they did is, usually they put sand below the ark. They build the ark, and after the ark is finished, they excavate the sand. It's a practical solution, but of course it only is good for small arks. After Egypt, we can jump to Greece. It was the second civilization. In Greece, the monuments, as you see, are structural. The structural concept of the monuments in Greece is very similar to the Egyptian one. You have the columns made by small elements. We have small beams. You see the space between the columns is small, and you have the footings here. You see here more in details again the footings, the columns, and the beams. The main problem in Greece is that Greece has much more earthquakes than Egypt. And so when an earthquake came, typically these columns collapsed completely. You can see here one is not this guy that put the column down. It's an earthquake that collapsed. And so most of them collapsed. And this was a problem related to this type of construction. Is there was no tension element, there was no glue. There was no glue among those elements of the columns, so collapse. And we come now to Rome. Rome, in fact, we had a big jump in construction techniques. Rome, in its greatest dimension, was this side. It included Egypt till England, as you see. It was all this area. And one of the main problems of the Roman Empire is all this area was controlled by this single town in Rome. And how could this be done? And remember that all this area were the enemies, so they had to defend all this border. And here, but here was nothing significant. So the strategy that Rome implemented was to put garrisons, places with Roman soldiers, and to have a very good system of roads, so it allows a rapid movement of the army to the conflict point. And basically, the Roman Empire had 80,000 kilometers of main roads and 400,000 kilometers of secondary roads. So it's an impressive system of communication that they developed to be able to withstand and support the control of this large empire. They developed techniques for the road construction with stones. You can see still some of them here in Portugal. It was system with drainage, with kilometers markers. At that time it was not kilometers, but are millions marks. And it was a pavement system that allows the movement of wheels. The chariots could pass here, pushed by horses, which allows a rapid movement. One of the main inventions of the Romans was not the ark, because as you see in the Egyptians had no ark, but this small detail that you can see here. This small element that they put at the top of the columns, it's an external element. And why this element is so important? Because this element allows to support here a wood construction that would support the ark till it is finished. And after that, you can pick up that wood construction, pass to the next one, and build next one. So they could do the ark at any height. It could be 20 meters if you want, because they only need this small element to put the support of the construction. You can see here more in detail. You can see here, basically is this small element here that allows the support of the wood construction. And after that, you build the ark and repeat these elements. The Roman ark is circular, mostly because it's the easiest way to build them and to repeat them. Typically, they repeat the ark, and with this technique, they could do it. They could do it repeatedly, or let us say, in an industrial way. Another element that was invented by the Romans was the stone glue, let us say, the mortar. They found that in a place, it was called Pozzuoli, close to the Vesuvian mountain, there was a kind of ash from the Vesuvian mountain, and that ash had a special property. When mixed with water, it becomes a glue that can glue the stones. It's what we call in nowadays mortar, okay? And they began to glue its construction. You can see here the bricks, Roman bricks. You see they are different. They have a better shape that the Egyptian ones, because the temperature really increased, and so the clay bricks are much better. But most important is they are glued already with mortar. Okay, it has a big advantage, because if you put mortar, you begin to have capacity to absorb the tensile stress and to have a better response to earthquakes. You can see here people with mortar putting the elements. You can see a detail of a wall with bricks and the clay and the mortar among them. Another element that was used for bridges and aqueducts is the construction of aqueducts. The most famous one is the Nimes aqueduct that you can see here. You see that the arcs are all equal at each level, but all this enormous construction was built to have this channel in the top. Here in the top, you have this channel, because the Romans did not knew a good system of pipes to pass valleys. So water has to be transported, let us say, in an open aqueduct till the final position. Basically, you can see here this was the concept. They could do tunnels and so on with a uniform inclination. What is fantastic, how they could do a uniform inclination all along several kilometers till they reach the town, where there was some fountains where people could get water. It's funny because in the towns they had pipes. They have lead pipes that was used for instance for gardens in even some houses. And as you know, lead pipes make that lead is something that is poison for people, and people taking lead can become crazy. And one of the theories that associates the end of the Roman Empire is precisely related to the existence of lead with water in the Roman Empire. And this theory arises because in the corpses that were found in Pompeii, they found an elevated level of lead in dead people there. Another constructions using the arc is bridges. This is the Alcantara Bridge. It's for me the nicest Roman bridge that exists in the world. It's a pity because, as you can see, there is Portugal, but it is 10 kilometers below the border. It is already in Spain, but you should go there because it's a magnificent bridge. At that time, it was during the Roman invasion of the Iberian Peninsula. This is the Tagus River. The Tagus River was a separation between the Roman occupation and the barbarians. Barbarians were the Lusitanians, okay, that were on the other side. So this was a kind of army protection with reinforcing of with army reinforcement here to protect this passage. Another construction element from this time is the dome. The Romans were the first people that built a dome, you can see, and the dome is a more innovative construction than the arc, because in the dome you have a 3D composition of the elements. Remember that in an arc, when you build an arc, each stone of the arc has a smaller length in the interior part than the exterior part. So the stones there need to be cutted with this divergence between the interior part and the external part, so that at the end they all fit in an arc. In the dome, you have to do that in 2 dimensions, in the perimetral and in the longitudinal directions, so they can fit all together. That is the problem of all these stones. But they were all glued with the mortar that they did, and you can still see this dome today in Rome. That is a magnificent construction. One of the most famous domes built later on was Santa Sofia Church, built in Turkey. At that time was Constantinople, and that was built for the Orient Empire of Rome. That was later occupied by the Turkish. Now is a mosque, and as you see here by the minarets that are after that. But it's funny because this contact between the Muslims and the Orient Roman of the empire led to the use in the Arab civilization of mosques, the temples of the Muslims, that basically use the dome as typically use the dome. You can see some of the mosques, most famous, that are used. In contrary, in the western part, in the Christian part, let us say during the Middle Age, the churches that are the most important monuments at that time use the arc construction. So it's the Roman arc, and instead of building a dome, they build a cylinder construction. So you can see typically this is the Lisbon main church, and it was done with a cylindrical ceiling plus a cylindrical that was here. That was the cross section where the intersection of 2 cylindrical domes were done in the special dome. So we have typical spherical dome for the Muslims, and we have a medial dome, a cylindrical one, in the Christian Western Middle Age. So basically you see the typical the Roman arc with that small support that led to the cylindrical dome that was used in the Western, and the spherical dome that was later used by mostly of the Muslim religion. After that, we reach in terms of evolution, around the 14th, 15th century, the Gothic construction. The Gothic construction is an evolution of the Romanic style. here I'm going back just to see this construction is called the Romanic style. And this Romanic style, as you know, when the arc, due to the pressure that comes from above, exerts here horizontal force that tend to open the arc. And to avoid this, typically these walls, the walls in this church, were very thick, very strong to absorb the impulse that came from the arcs from top. That is why in the Romanic style, these churches are very dark. They don't have windows, because to put windows meaning to reduce the weight of the walls. And the walls need to be very thick to absorb those forces. When we reached the Gothic style, the conception was different. The conception was to put the dome, let us say, supported by small arc beams. That small arc beams were the first, and these small arc beams would lead to the forces in columns. Besides that, the Gothic arc is an arc that, instead of the Roman arc that is circular, the Gothic arc has an height bigger than the width. So the forces that came from that arc are smaller. This allowed this type of construction, that is the Gothic churches of construction, and where you see that those arcs, you see here them, they will lead the forces to columns, and these allow that as they are in columns, these allow that the external walls are not so needed, or the weight of the external walls is not so needed, and they can have more windows. And that's why we have those nice glasses in those windows. Even so, there are some external forces that come from the arcs that need to be supported, and they did these reinforcing walls externally to the church to support these forces. Basically, you can see here in the Gothic construction, you have the Gothic arcs that are supported by columns here, and this is basically the church, and externally to the church, external to the church, you have these reinforcing walls that support the forces that came from the dome. This is a typical Gothic church. You can see here the Gothic church. This is the Notre Dame de Paris, that before the fire, does not exist anymore, and here are those buttresses that support the force come from the interior. You can see, just speaking about Notre Dame de Paris, hopefully what happened is, what burned is the wood ceiling that is above the dome, the stone dome. Now that's why there was no such a big collapse, because this burned, but except for a small zone, the stone dome supported the fire. One funny thing that can speak about those churches, the Gothic churches, is of course there was no structural analysis at that time, no specific design. The design of this church was mostly done with the experience of the previous ones, and this knowledge passed from fathers to sons, and the builders of these churches had this secret of construction, and they made a special group of knowledge for building churches, Gothic church, that was called the Masonry, that led to the present Masonry. That has nothing to do with that, but they still keep the symbol of the construction elements in these elements, because the origin is related to the special secrets related to the construction of these churches. After the 15th century, we enter in the Renaissance, and in the Renaissance appears one man that is kind of considered the father of the civil engineer. That man is known in the world not for civil engineer, but for a special detail. His name is Galileo. And you know that Galileo became famous because he discovered that was Earth that was going around the sun and not the opposite, as was said at that time. And he entered in a discussion with the church, and the church exiled him, and he accepted. At the end, he said, "Okay, I don't agree, but I accept that is the sun that is moving around the earth." And he was exiled by the church. The church was a bit afraid of his ideas, and the church only allowed him to study problems related to construction. Okay, and that's why Galileo began to do that studies, to study the behavior of a beam, what makes the collapse of a beam, and so on. So he's kind of father of the beginning of studies in construction. And these concepts began to be more deeply studied, and we begin to have treatises of construction with a better behavior of the materials. And you see that bridges begin to have smaller arcs or more lower arcs related to the knowledge that is increasing during this period. One detail that I always like to remember is the balconies. In those years, balconies built with stone, and this is, I use this picture because it's a famous balcony. It's the balcony of Romeo and Juliet, okay? And this balcony, if you look at it, it has a special characteristic. It is very small. You see, it's very small. And why it is very small? All the balconies in stone are very small, because when you do a balcony, you use the stone as a cantilever, is a beam in cantilever. And as cantilever it is, the tensile stress in the upper part is very weak. To support those tensile stress. So balconies in stone are typically very small. That is something that you can see here, for instance, in Lisbon, when you walk in the streets, to know if a building was built before reinforced concrete or not, is just to look at the balconies. If the balconies are small, it is a building made of masonry, of stone. If the balcony is big, means that it has already reinforced concrete, so it is something after the 50s or 60s. Okay, so they use this problem, of course, to be built with stone was not a real problem. Some variations were used to have these external elements. Now let us move a little bit. I have been mostly in Europe. Let us move to the Orient, to Asia. In Asia, the evolution of construction was a bit similar to Europe. You have arc bridges like here, but the main difference was the wood construction. They used very much wood construction, what we did not use so much in our monuments in Europe. And as they used wood, and wood is a material that supports well tensile stress, you can see here that typically the monuments, the temples in Asia are completely different from the temples in Europe, because mostly they can build larger cantilevers. You can see here larger cantilevers, what can be done, of course, with wood, but not with stone. Jumping to Central America or Southern America, that, as you know, Central America did not exist till the 16th century, basically, when Columbus reached there. The civilization so developed independently, and they also had temples. These, contrary to the Egyptians were tombs, here they were temples. And but these constructions were not like the Egyptian ones, because this is basically a cover with stone. These temples that you can see here, they are mostly done with earth. It's it's earth, and they just had a cover with stone. So in terms of construction, it's not a special achievement. A very fun thing is they in Central America, they did not use the arc to pass the instead or beams. They basically use this type of construction, what is called the false arc. So when they want to make a ceiling with stone, they just begin to construct this inclined. They put just here some wooden elements. When they reached that, it was okay. They could support each other. They take out the wood elements, and they had the ceiling. So the ceilings of the temples in Central America, they are all like this. They are like an inverted V, with what is something. In Europe, we had this for a few periods in that we can find some elements in Greece, but it's so complicated that it was not considered for the evolution. But in Central America, this was typically the ceiling that was used. They did some achievements. For instance, in seismic zones, they understood that the interlocking of the stones was very important, and you see how a wall was built. You see the detail of cutting these stones so they completely interlock. As a matter of fact, in the Peru, when the Spaniards reached there, they built over one of the Incas temples a church, the Spanish church, and when an earthquake came, the church collapsed completely, but the basic part that was the Inca temple remained completely well. Another funny detail is the roads. The Incas, that is mostly Southern America, Peru, they had a lot of roads, but they never used wheels. So everybody, the movement was walking. And do you know why? Why do you think that they have roads, they have large distance to pass, but everything was done walking. They never used wheels. And you know why? The reason is this animal. They knew the wheel, but they didn't have any animal to push the wheel. They didn't any cows or horses or whatever to push the wheels. The only animal they had is this one that you know well, but this animal is very irregular. You cannot put him pushing any wheels because it just go away. Okay, so that is funny because the non-existing of cows or horses led that only after the Spanish arrived, they begin to use the wheel. Well, and with this, I end the initial part of the construction. We reach the end of 18th century. And what happened in this 18th century? In this 18th century, in England, the iron material, so the iron that comes from mines to build steel or iron, usually comes with a lot of impurities. And to take out those impurities, we need to put fire on him and to heat him to burn the impurities. And in England, what they decided to do, because perhaps they begin not to have much wooden material to burn it, they used coal. And coal has a higher temperature. And with this higher temperature, the impurities that became associated to the iron disappeared much more, and they were able to get a better material. It was the first iron construction was this one. It still exists. It's a bridge. As you see, the bridge were made with arcs. So they built this first iron bridge also in arcs. But you see already one main thing that is it's much more transparent. See, the quantity of material that used to make a bridge with iron, it's much less than with stone. So because this material has much higher strength. And as they understood that the problem of the use of the iron was the temperature of burning the core, they increased that more. And after they got the hot iron, that is, well, let us say, the beginning of the steel, because the first iron, it had a good compression stress, but in terms of tensile stress was not so good. It was with the hot iron that appears already a material with good steel and construction. And that hot iron was for the first time used in the Crystal Palace in London in 1850. See, all these materials was built with steel iron, not steel, hot iron beams. It was what was used for the first time. They had to be approved this type of construction with this new material. Many tests were done to allow its construction. The appearance of this material in practice led to the Industrial Revolution, because with this, let us say that iron, it was possible to have furnaces with much strength. So we begin to use the power of the steam. Steam engines appear. With steam engines appear the trains. And to use trains, you need to have railways. To have railways, you need to have long bridges to pass the valleys. Okay, and this is precisely the beginning of the civil engineers, because till then the civil engineers, the concept of civil engineer did not exist. They were mostly military engineers, because our main constructions were to build fortresses for war and things like that. And it is precisely with these new materials and with the railways that some military engineers decided to become civil engineers instead of military. And they did the foundation in England of the first association of civil engineers that was dedicated mostly to the construction of the railways engineers. You can see here some of the biggest bridges that were built that time for the train. The train goes inside this, okay? This is mostly the knowledge. Remember that the knowledge, there are no fine elements or computers or whatever. So to be able to design these things, mostly were then models, almost full-scale models. They were tested. This is a part of a model of the bridge that is there, and they were really tested. And if they prove in the test, then they were used. So design of this bridge will take a long time, because they need to test almost all the bridge, because the bridge before the bridge was really bridge. It was in this time that in Portugal we had the problem. Our railways connecting Lisbon and Porto stopped in Gaia, because there was no bridge, and there was no way to build a bridge to cross the River Douro. And at that time appeared an engineer that you know, Gustav Eiffel, that became famous because he decided to study the effect of winds in bridges. Just coming a little bit back, with stone bridges, wind was not an effect to be considered. It is impossible to make the collapse of a stone bridge with wind. When we pass to steel bridges or iron bridges, as they are much more lighter, we begin to have collapse of these bridges. We had severe collapse, mostly in England, of this bridge due to wind. And Eiffel understood the problem, and he did several tests, and he understood that the wind should be considered as a pressure in steel. And he decided to do that studies, and he proposed to build an arc bridge for Douro River. It is here the construction of the Maria Pia Bridge, that was at that time one of the biggest in the world, and he has the advantage also of developing a new construction system that did not have to use the support of the arc before it is constructed, so it was supported from above. Just a small comment, it's only after Eiffel built the Douro Bridge the French allow him to build bridges in France. The experience was done here in Portugal. And after the steel, we reach the end of 19th century, where appears a new material, the concrete. The concrete is it's an artificial stone that has the problem of being good for compression but not good for tensile stress. And the legend says that one day a gardener, Joseph Monnier, that was specialist in building vases for plants, and vases for plants in concrete, but most of those vases would present cracks with development of the plants, and one day decided to put a steel grid inside the concrete, and the vases never broke anymore. And he patented that invention and appeared the reinforced concrete from a solution in vases. That evolved and led to the most important constructions in the 20th century. Curiously, one of the things that prevented the earlier development of the high-rise buildings was not a construction problem, was the development of the elevator that appeared only in 1852, and only after that we begin to have the construction of the scrapers. The present solution of buildings where we have a structure with beams and columns, and where the walls are not anymore the strength part of the construction, appeared in 1892 with this guy, Ennebic. It's funny, this guy was a person that had a material, basically a mortar, to protect steel construction from fire. So what he did basically was he went to the steel structures and put a mortar to protect those elements from fire. But he understood that the steel elements with mortar became very resistant, and he decided to build a building just with that. So it was the steel beams with mortar around, what is basically the concept of reinforced concrete, that he began to build, and he appeared the classical construction that we use today with what we call the column and beam structures, frame structures. Another element that appeared a few years later with the Freycinet was the pre-stressed steel. The concept is very easy. It's if concrete cannot support tensile stresses, we can pre-stress or pre-compress the concrete so we can absorb some tensile stresses till in decompression. So he developed that idea. Unfortunately, at this time, there was not enough steel with characteristics to implement this idea, and it was only at the end of his life that the first pre-stressed structures appeared in the world. Okay, so this is, let us say, an evolution of the construction till the 20th century. And what is the recent evolution? Just to have an idea, and now let us speak of the end of 20th century. If you look at the year 60, 70, at that time, there was not yet computers, though design of structures were built based on models. Now, perspex models and so on that were tested, and based on these elements, the structures were built. You can see here, for instance, a model for the São João Bridge, the railway bridge in Porto. This is one that at that time it had a span of 250 meters. That was the biggest one in the world in terms of railway bridge. This was a technique that was developed by a famous university professor, Edgar Cardoso, a bridge professor, that did several bridges, some of them world records, considering only the design based on models with techniques that he developed. Here are some elements. We still have some of these elements in our museum here in IST that you can go there and see. But after that, we had what we called the Big Bang, informatic Big Bang. Computers begin to appear. First, they appeared in our national laboratory. The first bridge that was slightly designed with computers, with fine elements, was 25th of April Bridge. And the IST had the first computer in 70s. And the first calculator, the simplified calculator with 4 operations, appeared in 73. We begin to teach the finite element elements in 76. And the first SAP, the great-grandfather of the SAP 2000 or whatever that you use today, appeared in 78. And with that, we begin already to design the same São João Bridge that Professor Cardoso designed with model. It was for the first time in parallel studied with the finite element method. And that's why I put this bridge, because it was the last great bridge designed with physical models, but it was also the first great bridge designed with numerical models. And since then, the first PCs appeared in 85, and the first seismic design of our cable stay bridge computer design was done in 86. These are the two in south in Algarve. And most recently in 98, we have already the design in the fluid dynamics. This is for the Vasco da Gama bridge. And we begin to do that with tests in active control, because wind is still the area where experimental tests are still needed, because computer models are not yet so efficient. And what about the future? The future is, as always, 3 words, as in the Olympics: higher, longer, and stronger. These are the 3 main words for a civil engineer. The higher, presently we have the Burj Tower with 800 meters, built in 2008, and is under construction, because a tower in Saudi Arabia with 1,000 meters. It seems that the main problem is money, so the construction is stopped. I don't know, it will finish. Longer, the longer bridge, the longer span that we have is with almost 2 kilometers, main span, is a Japanese bridge. And stronger, we begin to have the composite materials. We speak about carbon fiber nanotubes with a strength of 6 gigapascals. So this is This is what is leading into the change related to new materials. We begin to see now new materials. So remember that we did all our civilization with three materials. After we had the steel and concrete, and only now begins to appear new materials. We begin to have the composites. Here are some examples, bridges that we begin to see already their use. We begin to see new construction techniques. We begin to see, for instance, precast tunnels underwater, equipment for movements with high capacities. And just to finish these evolutions, I'm going a little bit back, and I'm going to travel now with you along Lisbon, okay? Because you are here from when you can walk in the street, what is not what we can do in our present days. I call your attention to see some of the buildings, because Lisbon has a particularity that has buildings from the old ages till the present ages, and we can see the evolution of building construction in almost all the streets. Basically, we have five typical constructions. We have the constructions before 1755, what we can call Middle Age construction. We have Roman constructions. Now you even have a site in web that you can look, that is about the Roman Lisbon, where you can see the several Roman monuments that you have, and you can see several examples of Middle Age till Roman construction. This date is the date where we had a big earthquake, and after that big earthquake, the construction changed, and we have a construction related to that period of reconstruction. It's called the Pombalina construction, because Pombal was the first minister that organized that construction. After that, we had an evolution of this construction. It was a bad period. It shows the beginning of the iron, but the quality of this construction began to be reduced. And till that, after that, we begin to the appearance of the concrete that appears only in some parts of the buildings, till we have the present situation of the reinforced concrete with the steel and beam frame solutions. Just to have an idea, you have the medieval construction before 1755 that appears around the castle in Alfama regions. So are small houses with an irregular architecture, basically walls in stone, sometimes poor stone. The floors are usually wood construction. Sometimes in the basic element we have some also stone arcs for some spans, but basically is a stone that is a poor stone, mostly soil and stone and bricks, a mixture, and what we call masonry. And we have wood construction. This is a very irregular construction without any special construction to support sides or whatever. In 1755, Lisbon had the earthquake. I'm going just to have an idea of what happened. This is the old Lisbon, you see, Middle Age Lisbon. So it was in this zone, not here, but more here. This is the tsunami. Okay, so you see an idea of the complete destruction. Oops. Temos uma. Sorry. Okay. So yeah, we had some fado associated. Okay, so but with that, you see that all this part was renewed after the earthquake. It's the present situation. And what they did is a new type of construction that was sought, and it was the first time in Europe that was sought to have buildings supporting earthquakes. And the concept was, as in the previous buildings, we had masonry walls, but they were completely free from the opposite ones. And the idea was to put walls connecting the opposite internal walls, connecting the external walls, and this connection was done with wood trusses. So they made a kind of box for the building. This was the new concept that was used, and you still can find in some of the buildings that are in the lower part of Lisbon. You can see the concept basically is to have all the internal walls were made of wooden trusses interconnecting the external walls, and so making a kind of box that could support the earthquakes. After that, to build these wooden trusses was a bit complicated and expensive. The construction began to do that without those trusses, and appeared a kind of construction more simplified. Just you can see here, there are many buildings, especially in the zone here close to the university, where you can see here that you see the balconies. They have small balconies, meaning that the floors are in wood. And basically what they did is similar construction, but without those reinforcing facades. Besides that, they begin to use, as fire was also another problem, they begin to have safe stairs behind, and they use the iron begin to appear there. You see, the main problem of these buildings, and this occurs with some frequency, as the construction is basically this, just the walls and wooden floors. These buildings, when you sometimes demolish one building that is connected to this one, if you have a small soil settlement, there is no capacity on this to support this soil settlement, and they have collapse. Mostly don't collapse, but they have severe cracks and so on. This is the area of Lisbon where we have today more problems in terms of construction, let us say. These buildings begin to have the introduction of the iron construction. You can see here that was used mostly in the external part mostly to support the toilets, because they understood that the toilets in a wooden floor would lead frequently to the collapse, because due to the water, the wooden could not support and they would lead to collapse. And they begin to put the toilets external to the buildings in these structures. And it's some reason that when concrete appears, around 40-60, concrete begins to appear only to do the floors of toilets and kitchens, because are the wet parts of the construction. But suddenly they understood that it was much easier to build the whole floor in concrete. And we have this type of buildings where we have still the walls have strength to support the floors. The walls are still in masonry, but the floors are already in concrete. That is called the mixed construction, let's say mixed, because you have walls in masonry and you have already floors, and you have already floors in reinforced concrete. Here you see that the balconies with concrete floors, the balconies begin to be larger, precisely because you have already concrete balconies. You have here the solution where you put reinforced concrete in the floors. And finally, we reach the present construction, that is the frame construction with beams and columns in concrete, and where the walls are not anymore an element of resistance, but they are more to protect inside. If you see here, the university is here, and this evolution is very much seen around the Home Avenue, because it begins with some wooden floors. After you have some mixed construction, and at the end you have already these buildings that are the present situation. So this is the buildings that you know, that you learn how to design are this, but it's good because if you do rehabilitation, it's good to know that there are all the other types of buildings that you may face, and they have a complete concept of solution. And that's all. Thank you to be here for 1.5 hours. Okay. I don't know if you have any questions. I can talk with Cardoso. I can perhaps put if the record works well, I can put that in the class, in the web, in the site of the class. Yes. And you want to say something?
I have one question more on the organization of the course. We don't exactly know yet how many students are registered. So I counted 23 before.